Hi, and welcome to How Do I BI, a mini-part screencast series on using SQL Server Analysis Services 2008. This is designed as a companion to the book Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett, a developer evangelist with Microsoft in Southern California. In this episode, we're going to have a screencast around the topic of implementing calculations using MDX in bids for SSAS OLAP cubes. Before we proceed to the screencast, we'll go over some FAQs and gotchas around implementing calculations. In terms of FAQs and tips, because of the complexity of the MDX or the multidimensional expression language, you're always going to want to verify the results of your calculations in the BIDS cube viewer to make sure that the MDX that you have written produces valid results and doesn't impact performance in a negative way. Writing effective MDX is a topic of scope beyond this particular screencast, and I would recommend one of several MDX books available on the market in order for you to understand the complexities of MDX. I also suggest that you review and use the included MDX templates in the calculations section of the BIDS browser in order for you to look at some MDX that is well written. In terms of gotchas, there are 3 different types of objects that you can create using the Calculations tab. Those are calculated members. Most typically you're going to write them in the measures dimension, but you might write them in other dimensions as well. And these are custom aggregations for any set of members in any particular space in the cube. Name sets, which are simply aliases for sections of the cube. And then the most powerful of all, the script commands, which allow you to do really anything within the realm of what's included in MDX inside of your cube. You want to verify your script scope and your calculation intersections if you have any, particularly if you create calculated members and dimensions outside of the measures dimension. And then you want to verify that your intended clients support the display of calculations. With this, we're going to go ahead and go over to the screencast. Screencast, we're going to take a look at using the Calculations tab inside of BIDS to add MDX calculations to OLAP cubes. What I've done here is I've loaded up the sample AdventureWorks DW and then opened up the cube in the BIDS development environment while double-clicking on AdventureWorks. And this now I've set to the Calculations tab. Before we look at the specific objects that we're adding, let's go ahead and run through the options available on the toolbar. The very first one we're going to come back to at the end of the screencast. This is Add Business Intelligence, and this is a wizard that allows us to create specific types of custom objects in a cube in a wizard-driven fashion. This is a refresh button, a connection button, and then we go over to our Create New Objects. We have 3 different types of objects that we can create. We can create calculated members, name sets, and scripts. As I mentioned in the introduction to the screencast, name sets are aliases for areas of the cube. Calculated members override the default calculation or aggregation for sections of the cube, are most commonly done in the measures dimension, but in other dimensions as well. And the script command allows you to apply MDX custom script to any section of the cube. It's very powerful, but also very dangerous. In any of these cases, you're going to want to verify the MDX that's created for validity and for performance. There are 2 views of this section. There's the default view, which is the form view that we'll go into a little more detail here in a minute, and then there's the script view, which gives you the complete script from top to bottom. In addition to this, we have the ability to switch users, and this allows you to test permissions. So let's take a look at the sample objects that are included in AdventureWorks. The very first one is a script command that sets the default member of the destination currency cube dimension, and all of these samples are pretty well commented. So you can see we've got syntax coding, color coding inside of here, and we do have IntelliSense that I'll show in just a minute. So blue is for keywords, and we've got our brackets defining our dimensions in our hierarchies. We're just setting an update here. Now it's very important the order that you create the objects, and you do have the ability to move things up and move things down with these buttons here, because they do execute in order and script objects can overwrite one another. This is particularly important if you're creating calculated members of non-measures dimensions, because they can intersect, or they will intersect, and you're going to want to control the intersection order. If you pass your mouse over the object in the script organizer, you'll see that the MDX script is shown for the object. For script objects, you just get the native script. For calculated members, you get the form view by default. If you want to see the script, you click on the script button, and then it will jump in the script to the full script for this. So let's go back to the form view first. So this is a member called Internet Gross Profit. Again, if you pass your mouse over it, you'll also get the script. And you can see this is created in the most typical dimension, which is the measures dimension. The reason the parent member is grayed out is because the measures dimension is flat. There are no hierarchies. And it's a very simple expression of simply taking the sales amount minus the product cost, and that's going to give us the gross profit. We have additional properties that we can set. We can set the formatting type, currency in this particular case. We have the sort of standard format masks here. You might be wondering about this option, visibility. The reason for this is you can create calculated members that are based on non-visible members. An example of this might be some confidential or information you wish to keep private, such as salary information. You can also set non-empty behavior here, and this is pretty self-explanatory, and you can associate a measure group if you wish. In addition, you can set color expressions, and you can set font expressions, and these can be simple or they can be based on functions. So in other words, color at X if you get Y result. In a previous screencast, we looked at KPIs, or key performance indicators, which have the values of 1, 0, or -1 for good, okay, or bad. So you can think of a calculation as a more specific kind of a KPI in that you can really define any expression rather than just a single 1, 0, or -1. So we have a large number of calculated members inside of this cube. And before we go on, an important point for you to remember when you're using any calculations in your cube is to make sure that your client application will support the display of these. So just to show you that the included browser inside of BIDS does support this, and it's a great way for you to validate your results, we'll just click on the browser tab, and what I've done is I've set it to bring the Internet Gross Profit calculated measure, which is indicated by the calculator icon on top of the measures icon in the measure group metadata view, and dragged it over to the browser so that we could take a look at it. So we go back to the calculations tab, and we see that we have a large number of calculated measures, which is typical. It's important for you to remember that the calculated measures calculate on query time and do not, their results are not stored in the cube and do not add to cube processing times, nor do they add to the cube storage space. There is a trade-off though for this flexibility, and that is the performance of a calculated measure is of course slightly slower than retrieving a stored measure. After the calculated measures, we have a set of objects called named sets. And if I pass my mouse over this, you can see that the underlying syntax is create set. And again, we have a form view here, and we simply say new product models, and we're using an existence test in this particular case. And we have two different display properties. We have static or dynamic, always shown or only shown when it's selected, and we can put it in a particular display folder. These are really just a convenience, like an alias for a part of a cube, and they often can make your queries more readable. So you can think of them that way. And as we scroll down into the sample, we then see we have some complex scripts, starting with an important keyword called a scope statement. Now this is very advanced, and I really caution the use of this. I've seen in people working with cubes, overuse of the scope statement done incorrectly can actually cause challenges in performance and challenges in readability of your code. What it does do, and here's an example, is it allows you to define for a particular area of the cube some custom calculation. So it's, again, pretty well documented. The scope statement here is asking you to allocate this value equally to the quarters in H2 of fiscal year 2005, and then it goes on, it uses this statement to do a further calculation, and then another scope statement, so on and so forth. When you're using a lot of custom MDX, obviously this is not very readable as a single script, so then you'll probably want to work with it in the script view. And what happens here is you get top to bottom, you can see it's a very long script, you get the whole thing in order, and as I said earlier, it is very important for you to understand that the order of execution is the order that the script is listed. So you can see we have a whole bunch of sets being defined, and after our sets, then we're going to go into the scope statements that we were looking at there, and what this is being used for is budget allocation and fiscal forecasting. Now, if you're not familiar with MDX, one of the challenges with working with the calculations section is how you can quickly get up to speed, and what I recommend is that you take a look at the included templates. We saw this in the previous screencast for KPIs. BIDS has the same thing, and inside of here you've got many different samples of the most commonly implemented both calculated members as well as named sets. And I have found in production situations that these can handle quite a few of the requests that you get coming in. So take a look at these. Also, we have included the functions, function browser, so you can use these to perform navigation and the stated functions that are here. And then of course we have metadata as well. Sort of a general rule of thumb when you're creating objects is use the easiest possible method because of the amount of time it generally takes new users to MDX to become comfortable with it. So dragging and dropping values into the form view rather than typing MDX is a way that we recommend for productivity. So just to show you how to create a new object inside of BIDS, we just click New Name Set, and then we can put in any value, my set for example. And again, this is generally for aliasing purposes. And then if I wanted to pull in certain values, I could just drag them and drop them from the measure group over here, or I could type them in. And then when I was completed, I would just save and then process the cube. No overhead is added because this is just really an MDX query. Again, this is showing that I need to fill this information in, and we do have syntax checking built in here, and that is shown by the little ABC, which is not a spell checker, rather a syntax checker. So the important takeaway here is the most common usages inside of the calculation tab is to create custom aggregations, most generally in the measures dimension for the convenience of end users. And my recommendation is to utilize all of the built-in metadata, functions, templates, and samples so that you can be productive adding calculations to your cube. Thank you.